Hi, and welcome back. This video is going to show you how to use Excel to plot the graphs associated with the Algae biofuel lab. Specifically, one graph that shows the absorbance and how that changes over time for the different treatments, and a second graph that shows the relative growth rate and how that changes for the different treatments over time. Now, if you don't have your data sheet set up or have already calculated the averages and standard deviations and the relative growth rates, be sure to do that before you move on. And you can watch the first video of these two to see how to set all of that up. Now, assuming you have everything, all the calculations done, what we can do if we scroll down on this data sheet is we can see the table that's for copying the averages and the standard deviations for each of these treatments. First thing to notice is it still shows the 2 or 3 or the 4 or 5. Again, depending on what day your lab meets, you might have done the first measurement on the second day or the third day, and then the third measurement on either the 4th or 5th day. We're assuming that the lab meets on Monday, so came back in on day 2 to measure on Wednesday, and then on Friday, which would be day 4. So we can type 2 and 4 to get this table ready to go. Once you've done that, we're ready to copy the values down. So we come back up to the top to the control treatment. We select the 4 cells for the averages, Control C to copy. We scroll back down, and if we come into this first cell, which is where we want the day 0 value, if we just do Control V to paste, you can see we get some weird numbers here. We get 0, 2, 4, and 7, which is not at all what we calculated before. And if you click on the cell and look up at the formula bar, you can see that what we did is copy the formula down the same way that we were doing before to calculate the averages for each of the different treatments. So what that means, if you click on this, you can actually see the 3 cells that Excel is calculating the average of. And so it's text, which it's a blank cell, and 0. So the average of that is 0. So we don't want that. So what we need to do is paste special. So if we come back up, reselect the cells, recopy the cells, scroll back down, come to our cell, right-click, and then what we want to do is paste the values. And you can see in the preview that we have the correct values showing up there. So click that to say yes, and now we can come back up to the data table and do the same thing for the standard deviation. Select the 4 cells, copy, scroll down to the second table, the standard deviation table, right-click, paste the values. We can do the same thing. I'm going to go ahead and copy the rest of the values down the same way, making sure to do the paste special to get just the values, and then we'll take a look at what to do next. Okay, you can see we have all the values for the averages and all the values for the standard deviations copied down. What we can see here, though, is we only have 4 rows. We have the control, high nitrate, high phosphate, and high nitrate and phosphate. And in this example, we had 5 groups. We had 2 different groups that both tested high nitrate. So we need to insert a couple rows so that we can have those values included as well. So if we click on the row right below that table, right-click, and insert, you can see we've inserted the row, and do the same thing for standard deviations. Right-click and insert. And we can actually save some typing by copying the average of high nitrate, pasting it below, and copying the standard deviation of high nitrate, and pasting it below. Now we call that first one high nitrate 1, and the second one high nitrate 2. So you want to be sure to change that here as well. Same thing with the standard deviation. Standard deviation of high nitrate 1 and the standard deviation of high nitrate 2. So we can go ahead and copy these values down, and then we'll be ready to make the graph. So now we have the 5 different experimental treatments that were tested. We have the control, high nitrate 1, phosphate, nitrate and phosphate, and high nitrate 2. So to make the graph, we want to select the entire data table like this, come up to insert, and what we want to insert is a scatter plot. You can see here, insert scatter XY. And we're going to choose the one that has the straight line connecting. Now, even though this isn't the graph that we want, this will get us started. So click to accept that, And now we have our graph. So Excel has tried to figure out what should be in the x-axis and what data should be on the y-axis, but it guessed wrong. Because if you look at this first data point, you see 0, 2, 4, and 7, and those might sound familiar because those are the days, 0, 2, 4, and 7. What we want to be graphing is the absorbance on the y-axis and time on the x-axis. So to fix that, you can see here under the chart tools if the graph is selected, and there's an option for switch row and column. So if we click that, now we have everything where we want it. So now we have days along the x-axis and absorbance along the y-axis. It's already color-coded everything, so we have the control in the darker blue, the high nitrate in red, the high phosphate in green, the high nitrate and high phosphate in purple, and then the second high nitrate in this teal color here. Okay, I zoomed out a little bit so that we can see all of the options as we start to adjust our graph. Now our graph looks pretty good. It's missing a couple key items though. The first are labels for the axes. So we don't know what the units are. We don't know what this is representing on the x-axis. We don't know what it's representing on the y-axis. In this version of Excel, we can come over to the plus, which is adding chart elements. Click this, and you can see the different options. We can adjust the axes titles, and so on. We want to add axis titles. If you come over to the arrow, it'll actually show you what some of the options are. So I'm going to just select the default, which are the axes titles, and you can see now we can enter in the x-axis, which is time in days, and we can enter in the value for the y-axis, which is the absorbance. We also need to give your graph a title. Chart title is not an appropriate title. It doesn't describe anything about what's happening here. So you want to come up with something that actually explains what's going on. I'm just going to call this example title because you need to do something better. Now we can see each of our lines is labeled. It's already been inserted. Excel has figured out the names of each of these data series because they're in the data table over here. So at this point the graph is actually in pretty good shape. The one thing that it doesn't include is any sort of measurement about what the variation is in the replicates around these points. And in that variation, what we're using to describe that are the standard deviations. So I'm going to move the graph down a little bit so that we can see all of our standard deviations on the table. Okay, I've expanded the screen so we can see everything that's happening as we add the error bars. So we would just repeat the step for each of the 5 lines. So we want to add error bars. Again, more options. It's going to ask what series. Now we're on to high nitrate number 1. Click OK. Come over to error bar options. In this case, we're seeing the options for the lines. What we want are these 3 bars for the error bar options. We want custom, specify value, a positive value. Select these 4 cells. Now we're on high nitrate 1. And then click the red arrow here. Select the negative 4 cells. Click here again. And OK. And same thing, we have these X error bars to get rid of. And again, you can barely see, if you look really carefully right there, you can see a bit of the error bar. Again, because the errors are relatively small, the error bars don't show up that well. I'm going to go ahead and do the rest of these error bars and then come back to meet you. Okay, I've added the error bars for all of the lines. I'm going to increase the size of the graph a bit so that we can get a better view of the error bars, which you can see here. Again, one of the main things that we're using the error bars to represent is how much variation there exists. And one of the reasons that we do that is to try to determine whether differences between points, between average points, are likely due to sampling error or something in the experiment, or if they are likely due to real changes. And what we typically use as a rule of thumb is that if the error bars for 2 points overlap, they're probably the same. It's probably close enough in terms of the average value that the differences might be due to sampling error. If the error bars don't overlap, like we see here, then that suggests that there actually is a true underlying difference. If you take a statistics course, you'll learn more about how to do a formal test, but that's basically what we're looking at as far as our example goes. So what we can see if we look just at day 7, this value here, which is the average in blue, and this value in green, which is the high phosphate, are basically the same. And if we look even back to day 4, day 2, and day 0, we can see that there isn't much difference here. So based off of this particular example, we might conclude that adding extra phosphate doesn't make a difference in terms of the overall growth of algae in an experiment. We can also look at these two lines here. So this gives us the red, which is the high nitrate 1, the sort of teal color, which is high nitrate 2, and we can see that they actually end up at about the same spot. Can't really see error bars on here. The values were pretty similar for each of the replicates, so small standard deviation, but again, we can see that they're pretty similar. But if we look back at day 4, we can see that there is quite a bit of difference here. So there's something going on between these two groups that led to some differences in the overall growth. And we can actually see all the way back to the very beginning that the high nitrate 2 started off at a higher value than the high nitrate 1. So maybe there is some difference in how that group added the algae initially that led to these differences in the overall growth rates. The one that's the clear highest growth, though, is in purple here, which is the high nitrate and phosphate. So this is twice the amount of nitrate and twice the amount of phosphate. Actually, sorry, it's 4 times the amount of nitrate and 4 times the amount of phosphate. Each of the high treatments were 4 times baseline, 4 times the control. So at this point, we have our graph. We can see the increase. Some of the questions that you're going to need to think about is, are any of these curves showing density dependence? Are the curves, are the population sizes starting to not increase as much as time goes on, which represents more algae as the absorbance increases. So more algae is potentially more competition for resources. As we get more competition for resources, growth rates might slow down. Do we see that in all of the treatments? Do we only see that in some of the treatments? Are there any treatments that look like they're not experiencing any resource limitation yet? So some of the things to think about for your lab assignment. Now, this graph, again, with a correct title is pretty much done, and you can copy and paste this into a Word document to print out and turn in next week or the following week with the lab assignment. If we keep scrolling down, we can see the tables for relative growth rates, and this is actually going to be all the exact same steps. So I'm not going to walk you through it this time, but you're going to copy the average and the standard deviations. Now we're looking at the relative growth rate, so we'll be selecting the average and then the standard deviation for each of the different treatments, coming back down to the table, pasting them in, adding, again in this example with 5 treatments, we need to add the extra row for the high nitrate 2 and the extra row for the high nitrate, or for the standard deviation for the high nitrate 2. So I'll go ahead and do that and fill it in so you get an idea for the graph. But like I said, all the steps are going to be exactly the same as what you did to create this graph, just with different values. Okay, all the values for the growth rates are copied into the tables. And what I want to show you is how quick doing these graphs can be once you know what you're doing and once you have a little more experience. So we select all of the points, insert our scatter, same issue where we have the X and Y confused, so switch row and column, and now we have our values. We want to add the axis titles. Now the x-axis is time period. The y is relative growth rate. Title is example title. And so here's our graph. We can insert error bars. Okay, there's the finished graph with the error bars. You can see, especially for this first time period, some of these error bars are pretty big, so that's something that we might want to look at and double check. But other than that, these graphs are good. You can copy and paste them into the assignment and answer the questions. Thanks.